Welcome to Debug Log, software engineering war stories, architecture decisions, and lessons learned the hard way. Let's dig in. Even for a company like Netflix, which basically invented the modern recommendation engine, the classic approach seems to have hit a wall when it comes to subtle user preferences.
That's the essence of what their recent work on GenRec suggests. Despite years of iterating on sophisticated traditional models, they identified a clear ceiling in how much nuance those systems could capture, especially with unstructured data like movie descriptions or user mood.
So the solution is, perhaps predictably, large language models. But the surprising part is that even LLMs aren't a silver bullet. The core challenge they're facing isn't just getting an LLM to recommend something, but managing what they call the cost of context.
Exactly. It's the paradox of LLMs in production. Their power comes from context, but context is also their biggest bottleneck in terms of computational resources, latency, and token limits. It turns out that getting an LLM to understand a user specifically, at scale, is an incredibly expensive proposition.
It's fascinating that Netflix, which is practically synonymous with algorithmic recommendations, is investing so heavily in this shift. What was the driving force? Their existing systems already seemed incredibly effective.
The blog post highlights a few key limitations of those traditional systems. While highly optimized for common patterns and explicit features like genre or cast, they struggle with what the authors describe as semantic understanding. Think about it. A traditional model might know a user watched a lot of sci-fi. An LLM, on the other hand, can process the description of a sci-fi film and understand the specific subgenres, themes, or emotional tones that resonate with the user, even if those aren't explicit tags.
So it's about moving beyond explicit metadata to the implicit, nuanced meaning, like the difference between action movie and a gritty, character-driven narrative exploring moral ambiguity within a dystopian setting.
Precisely. Traditional models often use embeddings to represent items and users in a high-dimensional space. These are powerful, but they abstract away some of the rich natural language semantics. LLMs bring in pre-trained world knowledge and a deep understanding of language structure, allowing them to infer connections and preferences that a purely statistical model might miss. They can grasp, for instance, that someone who enjoys documentaries about space exploration might also enjoy a sci-fi film with a strong scientific basis, even if the traditional genre tags don't immediately link them.
And this extends to user behavior as well. Traditional models look at watch history, ratings. Can an LLM infer more from that?
It can, potentially. By processing sequences of watched titles, genres, and even descriptions of those items, an LLM can build a more coherent narrative of a user's evolving taste. It moves beyond just user X watched ABC to user X seems to be exploring themes of personal redemption lately, often within historical dramas. This is where the concept of few-shot learning becomes relevant, where the model can generalize from a handful of examples of what a user likes or dislikes.
That sounds like a significant leap in personalization. So how does this GenRec system actually integrate LLMs? Is it replacing their entire recommendation stack?
Not entirely, and that's a crucial point. The authors describe GenRec as a two-stage architecture, which is common in recommendation systems. The first stage is retrieval, where a vast pool of candidate items is narrowed down to a more manageable set, say a few hundred or a few thousand titles. This stage still heavily relies on traditional, efficient methods. The LLMs come into play in the second stage, ranking.
So the LLM isn't sifting through millions of titles from scratch. It's taking a pre-filtered list and then applying its nuance to order them.
Exactly. This is the LLM-Native ranker that the blog post focuses on. The LM receives a prompt that includes the user's past interactions, their watch history, possibly their ratings, and a list of candidate items with their descriptions. The LM's task is then to assign a relevant score, or even directly rank these candidates based on the provided context. It's essentially performing a highly sophisticated, context-aware comparison between the user's inferred preferences and each candidate item.
And this is where the cost of context really hits home. How do they feed an LLM a user's entire watch history plus descriptions of 1,000 candidate films when these models have strict token limits?
That's the fundamental challenge they highlight. The context window of even very large LLMs is finite. One can't just dump everything in there. Imagine a user who has watched thousands of titles over years, and there are 100 candidate movies, each with a detailed synopsis. That quickly exceeds typical token limits. This constraint forces them to be incredibly strategic about what information gets passed to the LLM.
So it's not just about what information to use, but how to summarize and select that information effectively without losing the very nuance the LLM is supposed to provide.
Precisely. The paper discusses several strategies. One is user history summarization. Instead of listing every single title a user has ever watched, they might generate a concise summary of their recent viewing habits or overarching preferences. For example, user frequently watches suspenseful crime dramas and historical documentaries, but avoids reality TV. This reduces token count dramatically while retaining key signals.
That sounds like a mini LLM or another model creating that summary for the main ranking LLM, a recursive problem almost.
It could be another LLM or more traditional methods extracting salient keywords and themes. The goal is to capture the essence of a user's taste in a compact form. Another technique mentioned is selective context for items. Instead of feeding the full synopsis, cast list, and genre tags for every candidate movie, they might extract only the most relevant attributes based on the user's recent interactions. If the user just watched a sci-fi thriller, the prompt might emphasize the thriller aspect of new candidates.
So it's a constant balancing act, maximizing the relevant signal within a fixed token budget. It reminds one of trying to pack for a trip with a strict luggage weight limit. One has to prioritize what's essential.
A very apt analogy. And it's not just about summarization. They also explore prompt engineering extensively. How one phrases the instructions to the LLM, what examples are provided, few-shot learning, and the order in which information is presented can significantly impact its performance and efficiency. A well-crafted prompt can guide the LLM to focus on the most important aspects, effectively compressing the context it needs to consider.
Beyond the token limit, what are the other facets of this cost of context? It's not just about whether the information fits, but what it costs to process it.
That's the other major component, the computational expense and the resulting latency. Running an LLM, especially a large one, for every user, for every recommendation request, even with condensed context, consumes significant computational resources, GPUs, memory, and energy. This translates directly into monetary cost and, crucially, latency.
Latency is huge for a real-time system like Netflix. Users expect instantaneous results.
Exactly. If fetching recommendations takes an extra second because an LLM is processing a complex prompt, that's a degraded user experience. The blog post implies they've made significant strides, but it remains a critical engineering challenge at Netflix's scale. They're not just deploying an off-the-shelf model. They're optimizing inference, potentially quantizing models, and deploying them on specialized hardware to meet those stringent latency requirements at Netflix's scale.
This isn't just about token count. It's about the entire inference pipeline. So the cost isn't just about the number of tokens, but the entire infrastructure bill to make this work at a global scale for millions of users with sub-second response times.
Absolutely. It's a multi-dimensional optimization problem. They're trying to maximize recommendation quality, minimize latency, and manage the underlying infrastructure cost, all while dealing with the inherent computational intensity of LLMs. This is where hybrid approaches really shine, using traditional models for the heavy lifting of retrieval, and then bringing in the LLM for the fine-grained contextual ranking, where its unique capabilities add the most value.
How do they actually measure if these LLM-powered recommendations are genuinely better? It's one thing to say they're more nuanced, but does that translate to users watching more or being more satisfied?
That's the ultimate test. The authors describe a multi-stage evaluation process. It starts with offline metrics, which are standard in recommendation research, things like NDCG or AUC, area under the curve. These measure how well the model ranks items that are known to be relevant to a user based on historical data.
But offline metrics don't always capture the full picture of user experience. What about the subjective feeling of a good recommendation?
That's where online A/B testing comes in. It's the gold standard. They deploy the LLM-powered ranker to a small percentage of users and compare their engagement metrics, Things like watch time, number of titles started, or even explicit feedback like thumbs up rates against a control group using the existing system. The blog post indicates positive results from these online experiments, which is why they're continuing to invest in GenRec.
That's a crucial detail. Positive A/B test results mean that despite the engineering hurdles and the cost of context, the enhanced nuance provided by LLMs is actually leading to better user engagement.
It suggests that the qualitative leap in understanding user preferences and item semantics is significant enough to justify the increased complexity and cost. However, it also brings up the black box challenge inherent in LLMs. While LLMs can generate explanations for their recommendations, understanding why a particular recommendation was made can still be opaque, which complicates debugging and bias detection.
That's a fascinating trade-off. On one hand, LLMs offer the potential for explainable recommendations, like a user might like this because it shares themes of redemption with X, Y, and Z they enjoyed. But on the other hand, the internal mechanics of how the LLM arrived at that conclusion are often difficult to interpret.
Exactly. The explanation is often an output of the LLM, generated based on its internal state, rather than a transparent window into its decision-making process. This means engineers still need robust monitoring and evaluation frameworks to detect and mitigate issues like unintended biases or hallucinations, where the LLM might generate plausible but incorrect information. For instance, recommending a film based on a non-existent plot point.
So, looking ahead, what are the major future directions or remaining challenges for Netflix in this LLM-native recommendation space?
The authors point to several areas. One is continued innovation in context management. They envision more dynamic and personalized ways to summarize user history and item attributes, perhaps even generating different summaries based on the current viewing session or user intent. Another is exploring LLMs for the retrieval stage as well, though that would significantly escalate the computational cost even further.
Using LLMs for retrieval implies a massive increase in the number of items the LLM would have to process. That sounds like an even higher cost of context.
It would be, but it could also unlock even more novel and unexpected recommendations. The goal would be to leverage the LLM's vast knowledge base to identify relevant candidates that traditional collaborative filtering models might miss entirely. They also mention personalized prompt generation, where the prompt itself is dynamically tailored to the user, and multimodal recommendations, incorporating visual or audio cues beyond just text descriptions.
So the immediate focus is on refining the ranker and making context management more efficient, but the long-term vision involves LLMs permeating even deeper into the recommendation pipeline.
That's the trajectory. It represents a significant architectural shift for recommendation systems, moving away from purely feature-based and collaborative filtering approaches to one that heavily leverages semantic understanding and world knowledge. The cost of context isn't just a technical hurdle, it's a fundamental economic and engineering constraint that dictates the pace and scope of this evolution.
This exploration into Netflix's LLM-native ranker really highlights a fascinating tension. What are the key takeaways for listeners?
First, even highly mature, optimized systems like Netflix's traditional recommenders eventually encounter limitations that LLMs are uniquely positioned to address, primarily in nuanced semantic understanding. Second, the power of LLMs in production systems is inherently tied to their ability to process context, but this context comes with significant computational and latency costs. The cost of context isn't just conceptual, it's a very real resource constraint.
So it's a trade-off, more nuanced recommendations, but at a higher operational cost and with a more complex engineering challenge.
Exactly. And third, overcoming these constraints requires sophisticated engineering strategies like clever summarization, selective attention, and prompt engineering to compress essential information within the LLM's finite context window. It's not just about having a powerful model, but about intelligently feeding it the right data efficiently.
It also underscores that successful large-scale AI deployment isn't just about model performance, it's about the entire inference pipeline, from prompt design to hardware optimization, all aimed at delivering results within tight real-time constraints.
Indeed, it forces a reevaluation of how much context is truly necessary and how to distill it effectively for each user interaction.
Looking at this, how might the cost of context shape the broader adoption of LLMs in other consumer-facing applications, beyond just recommendations? Will we see similar optimization challenges elsewhere?
And conversely, will future LLM architectures evolve specifically to reduce this cost, perhaps through more efficient context handling or different forms of memory?
That's a wrap on this debug log. Join us next time for more engineering war stories and hard-won lessons. If any of this hit close to home, subscribe and tell your team.
Ship it carefully.